In this video, we are going to look at some counting problems very similar to those we had in the last video and last in-class activities. We're going to be looking at binomial coefficients. So we're first going to introduce the formula and notation for the quantity. The way we say that is n choose k. We're going to look at the expansion of x plus y to the n. In other words, we're going to think about what happens when we multiply that out for different values of n. We're going to look at the x plus y to the 2 and x plus y to the 3 and figure out how many times each term appears in those when we multiply them out. And we're going to introduce the connection between doing that expansion, that x plus y to the n, and those binomial coefficients is what they're called, n choose k. So just as a review, let n and k be natural numbers with k less than or equal to n. In the last activities, we looked at three very different sounding problems. Turns out these problems had very much the same answer, the same number. So if we're looking at a set with n elements and we want to know how many subsets have k elements, that is exactly the same as looking at all the bit strings that have length n and weight k. And that happens to be exactly the same as the number of shortest lattice paths between the points 0, 0 and k and minus k. And we're going to give that number that describes all three of those a name. It's a parentheses with n on top and a k on the bottom. And the way we say it is n choose k. And the way we found it is we first got an approximation that looks something like this: n times n minus 1 times n minus 2, count down all the way to n minus k plus 1. We discovered that that was too much. In fact, we counted every possibility k factorial times. So to compensate, we divided by k factorial. And then if you want a slightly more compact looking formula for that, if you multiply the top and bottom by n minus k factorial, you end up with n factorial on the top, k factorial, n minus k factorial on the bottom, and that's an alternate definition of an alternate formula for that number. So now we're going to look for a fourth problem that looks even more different, more separate from the other ones that we did. So we're going to look at the binomial x plus y. And x plus y, x and y are just variables. And we're going to look at a natural number n. And we're going to look at the polynomial x plus y to the n. So what does the expansion look like? And what I mean by expansion is just what happens when you multiply everything out using the distributive property. And you've done this in algebra, in your algebra classes before. So some of this is going to be somewhat familiar. So one thing you would do is you would line up the factors of x plus y. You'd have x plus y times all the way, however many factors of x plus y you have. You would choose one term from each factor. You have two choices, right? You have an x and a y. And then once you make those choices for each factor, you'd multiply those terms that you chose together. And then you do it again in all the possible ways that you could do it. Just make sure not to do the same one twice. And then what you'll notice is a lot of those terms are going to be the same, so you combine those like terms and get a more compact form. So you've done this when you squared things, x plus y squared. So you line up the x times x plus y times x plus y. And then you choose one term from each of those factors and in all the ways that you can. So the first way you might do it is choose an x in both of them. So the x in the first one, x in the second one, and you multiply those together. Then maybe, I don't know, you choose an x in the first one and a y in the second one. That's different than what you did before. You get an xy. You've done all the ones where you choose x in the first one. So I guess now we got to choose y in the first one, and we could choose, I don't know, x in the second one. You get y times x. And then the only way that you haven't chosen so far is y in both of them, where you get y squared. And then you look at those middle two terms, and they're actually the same number, and so you can combine them. Right? Combine those like terms. And so you end up with x squared plus 2xy plus y squared. And that's something that you probably did in your algebra class a lot. So I want to sort of make some observation of some of the patterns in here, because we're going to be doing higher powers of x plus y in a bit. And we want to make some observations to make those computations a little easier. So first of all, each term has two variable factors, right? So it has x squared, xy, y squared, right? So you have two x's, an x and a y, or two y's. So each of those has two factors that are variables. And also notice that when you multiply them out, you have coefficients of 1 for x squared. You just got plain old x squared. That's the same as 1 times x squared. Plain old y squared, that was 1 times y squared. But for xy, you got a different one. You got a coefficient of 2. And so I wanted to think about both of those when we're thinking about how we're going to do x plus y to the 3. So first of all, in this one, we're going to have 3 different factors. So each time we multiply something out, we're going to take a variable from each one. Each of those terms is going to have 3 factors instead of 2. That's not terribly surprising. So, I mean, we're either going to get x cubed, that's 3 x's, x squared y, that's 2 x's and a y, xy squared, that's 1 x and 2 y's, and then y cubed. Those are all the possibilities. And if we want to look at every way that we can choose the 3 factors, that is going to be extremely annoying and a little bit hard to organize as well. And even more so if we're, say, taking x plus y to the 10th, right? So once we get to higher powers, we want better ways of doing this. So what we want to do is try looking at each possible term that we get as our output, which we have, as you can see in that first bullet point up there, we have 4 choices, right? X cubed, x squared y, xy squared, and y cubed. All right, so if we have x plus y to the 3, that's what happens when we line them all up. So if I want to do x cubed, how am I able to choose 3 x's and no y's? Well, there's only one way I can do that. I got to choose an x in every single one. So there's one possibility, you get a coefficient of 1. So it's going to be 1 times x cubed. And same thing for y cubed. There's one possibility, our coefficient is going to be 1 again. Now for x squared y, we have a couple ways we can think about this. So first of all, once we can ask ourselves, how many ways can we choose those 2 x's? Because once we've chosen those 2 x's, the factor of y is automatic. So for instance, if I choose the first 2 to be my x's to get my x squared, I have no choice but to choose y for my third one. Right? So that's one way. So x, y. If I choose the first and the third one for my x's, I have no choice but to have the second one for my y. So that gives me x, y, x. And there's only one way I can choose 2 x's, one more way, because I can choose x's for the last 2, and then I'm forced to choose y for the first one. And those are the only 3 ways I can do it. That gives me a coefficient of 3. So I'm going to get 3x squared y. Now that's not the only way I could have asked that question. I could have asked, well, okay, I asked how can I get 2 x's? Maybe I can also ask, how can I get 1 y? Because again, once I've chosen the y, the 2 factors of x are automatic. For instance, if I choose y to be the first one, I have no choice but to get my other x's from the second and the third one. Right, so that gives me y, x, x. If I choose my y to be from the second factor, I have no choice but to get my x's from the first and third factors. So I get x, y, x. And if I choose y to be the third factor, which is my last choice, I have no choice but to get 2 x's from the first 2 factors. So that gives me x, x, y. Once again, I get a coefficient of 3, just like before. So the answer is the same, but you get it using a different technique. So here's our general strategy about how we're going to find these coefficients. So first of all, we want to identify what are the terms of the expansion, right? For x plus y squared, we had x squared, xy, and y squared. For x cubed, we had x cubed, x squared y, xy squared, and y cubed, right? So in general, what are the terms going to look like? And then focus on one term at a time and use our counting techniques to find the number of times that term is going to appear, and that will give us our coefficient. So our big question here I want to ask as my departing question is, what is the connection between finding those coefficients that we were looking at in those binomials and the n choose k numbers that we were looking at with the subsets, the bit strings, and the lattice paths? Well, n choose k, they are called binomial coefficients, so there is a connection. And what you're going to do is use those counting methods to find how those 2 things are connected. Well, I should say how those 4 things are connected, because this is the 4th one of the group. All right, so now I think you're ready to look at the PDF file called Binomial Coefficients, and that's included with this video.